All right, so I decided going to talk about geometry today, and so I know I got some questions before from students, but I haven't never had a chance to discuss those problems. Okay, there's some problems are easy, some problems are really tricky. I want to begin with the following problem. Okay. Well, let's begin with this easy problem. Okay. So if we have a rectangle, okay, as this is a rectangle. Remember this problem, right? And here's this edge side is 40. Okay. Now the question is, if we cut in the middle, okay, you get two rectangles. Then the ratio of the length to the width will remain unchanged. Okay, that means the ratio of the length to the width of the original rectangle is the same as the ratio of the length to the width of the new rectangle. Okay, so if so this is W, the width. Okay, if the ratio of the length to the width of the original rectangle is equal to the ratio of the new the ratio of the length to the width of the new rectangle. Okay, so what is the width of the original rectangle? Okay, so question, what is W? Okay, I think if you understand this problem correctly, okay, then it's easy to figure it out, just because when you look at this, this is a middle point, okay, middle point, we cut in the middle, right? So the new rectangle, okay, the width is going to be 20, it's already done, fixed. The length is going to be W, okay, the length is W. So the ratio of the length to the width of this is a new rectangle, okay, should be equal to the length over the width of the original rectangle. Okay, so then you get the identity. Once you get the identity, then you solve the problem. Okay, then you solve the problem. Okay, so then it's easy, like omega square equals, 20 times 40, it's 800, right? Then omega is going to be square root of 800. Square 800 is square root of 8 times square root of 100, right? So square root of 8 is 2 times square root of 2, here's 10, so it's 20 over square root of 2. Okay, so that's how do you do that. Okay, there are some other problems similar to this, but a little more complicated. It's like, the golden number, like how to get the golden number, okay? And there's some ratios should be, should satisfy should have some properties. Then you get an equation, you solve it, okay? All right, so this is a problem I want to talk about. Another problem is actually there are two types of problems. Yeah, I want to discuss the two types of problems. Yeah. Okay. Well, let's take a look at this one. This was the the two type I want to talk about, and this is a right triangle, okay? And here's another triangle, okay? So let's use A and the B and the C and the D, okay? So we know that AD equals DC plus 9, okay? And I also know that this side, let's call it 39, this side is 15, okay? We want to find out anything, find the BD, okay? And then you also find the DC. Then you find the AD, okay? That's the first question, okay? We did then another question I will going to go to you. I want to ask you to discuss will be a line bisect the angle. So let me discuss this problem first, okay? So this is a right triangle, right? So the first thing you have to do is a BD, DC. You know, you find the other side. This is a right triangle by the Pythagorean theorem. Is going to be 39 squared minus 15 squared. So this is going to be 36. Okay. Then you will get so you then all have you apply the Pythagorean theory to this large triangle. So now if you want to find the BD, so this is called the X, okay? And this will be 36 minus X. Okay, and the AD I call the Y, okay? So I know that Y is going to be 36 minus X plus 9, okay? Then I need another equation because this equation has two variables. So what is another equation? Okay, another equation will be 15 squared plus X squared is going to be Y squared. So what do you have to find? You find the BD, right? Find the X. Then it's simple now. So this is going to be 45 minus X, okay? So you have to plug the first equation into the second one. So 15 squared plus X squared, and the Y is 45 minus X squared, okay? Right? Then you just need to find X, right? You find X, you can get Y. You can also get DC, so 36 minus X, okay? So it's going to be 45 squared minus twice of 45 is 90, X plus X squared. So X squared cancelled out. Okay, so 90X equals 45 squared minus 15 squared. Now, how do you simplify without using calculate? Right? You see, 45 is going to be 3 times 15, right? So that's why you have to 3 times 15, 3 squared times 15 squared minus 15 squared over 90. So you can take a 15 out. So then 3 squared minus 1 is going to be 8. And here's 90, okay? Okay, so then you can try to, well, yeah, I'm going to multiply this out. The 8 is going to be, it's going to be 2 cubed, 3 square, and 5 square. Okay, and the 9 is going to be, 9 is going to be 3 square, 10 times 5, right? Right. So then you cancel 3 square, and you cancel this here, and cancel that. So you're going to 20. Okay. So X is 20. Once you get 20, then you can get Y, get Z, this is just apply the Pythagorean theorem twice, okay? Now, I'm going to ask you to do the next problem. I gave you the time, still 39. This is a 15, okay? A and B and C. I'm going to draw the line, which is bisect this angle. So this is a D. Find the AD, BD, and DC, okay? If we find one of them, you probably can find the rest of them. Okay, this is a little bit more difficult than the above problem, but I hope maybe we can call this one x, this is still y. Okay, I give you a hint, right? This will be 36 minus x, so make it easier. Just need to find x and the y. So DC is going to be, this is a x, this is a y, this is a 36 minus x. Okay, so try this. Can you solve the problem? All right, have you got it? So that's enough time. All right, so you, of course, you can apply the Pythagorean theory, right? So you get y squared equals 15 squared plus x squared. And that's it. That's not enough, right? You only have two variables. You have two variables, but only one equation. How to get another equation? The last problem, you are given the relationship between x and y directly, but here we are not given. But you have to use the condition AD bisects this angle. So you haven't used that property yet. So how can I use this property? So these two angles are the same. So the idea is very simple. You need to draw addition line. This is right angle, right? So those two triangles are equilateral. No, they are congruent. Those two triangles are congruent. Why? Okay, those two triangles are congruent. All right, why? Because those two angles are same. So those two triangles share one side, AD, and the corresponding angle are same, right? Corresponding angles are same. So this will be the x, right? Right? And how can I apply the Pythagorean theory? So you have to apply the Pythagorean theory to this triangle. okay? Then this side will be 15, right? And this side will be 39 minus 15 will be 24, right? Right? So 15 plus, 24, okay? Then you can get a new equation, okay? X squared plus 24 squared equals 36 minus x squared. Great, okay? Right? Then you can determine the x immediately. You don't need you don't need the first equation if you just want to find the x, right? So x squared plus 24 squared equals 36 minus 36 times 10 to 72 x plus x squared. So x squared is cancelled out, okay? Then 72x equals 36 squared minus 20. No, minus 20, yeah. Yeah, so you can, okay? So x is going to be 36 squared minus 24 squared divided by 72. So let's figure out what is that, okay? Let's figure out what is this, okay? So we can, if you don't want to use a calculator, you can factor this numerate, okay? And otherwise, just if you use a calculator, then then you get 10. Yeah. So x is going to be 10. Then you can get y, right? So y squared equals 15 squared plus 10 squared, and that is not going to be a good number. So what I'm going to do is 3 times 5 and 2 times 5. So I get 5 squared, and 3 is 9 plus 4, right? So 5 squared times 13. So y is going to be 5 squared of 13. Okay. So this is how do we solve the problem. All right, great. See, some geometry problems are a little more difficult because you have to draw addition lines. Okay. I asked this problem several times, but I want to show it to you again here. So now I have an equilateral triangle. Okay, so B and A and C. So triangle ABC is an equilateral triangle. Okay. And what I'm actually trying to find out is what I'm going to do is I change the problem a little bit, okay? I draw the circle around the B. Oops, circle. Then I draw the line from here to here, okay? So D and E. So I want to find out the ratio BE over AC, okay? Probably it's the same problem, just show you, right? And then you can keep doing like that and get another circle. Then you have a sequence of lines, right? And you can even draw another circle, Then you get another lines, right? And keep it going. So it's getting shorter and shorter. Maybe can we find the ratio? Okay, if it's a ratio, does it depend on size or not, right? So what I'm going to do is I call this side is A, okay? And this side is B. I want to find the B in terms of A, okay? Right? So how do you solve this problem? Well, first of all, First of all, you needed to find out this height, okay? And this height, let's call the B and F, right? So B and F is going to be square root 3/2 times the H, so BC. BC is going to be, already is going to be, we know the A is because it's an equilateral triangle. Equilateral triangle means AC equals BC equals AB equals A, okay? And that is definition of equilateral triangle, okay? So BF is going to be, this is a special triangle. Here 30 degree, right? This is B and that's F, that's a C. And this side is A. And of course, this side is this. This side is half of it, okay? But you know that BD, right, is going to be the radius of that circle. It's going to be, so BF, right, is going to be BE, right? So that's all that equal to square root 3/2A. Okay. What we have to find out is we find out the DE, but the DE is going to be, this is another equilateral triangle. So that's why this is going to be DE. So DE is, this is just our B, is just the square root 3/2, okay? So our ratio here, yeah, this implies, yeah, DE over AC is going to be B over A, aka C, right? So B is going to be square root 3/2A, and A canceled out. A is canceled out, sorry. Yeah. Okay, so this is how do we find the ratio? Yeah, it's a little bit tricky here, you know. You can BD, you can find the BD quickly based on this, you know, the circle. Okay. There's another problem in geometry. It's yeah, this is yeah, this is also a pretty tricky problem. If you have a rectangle, right? You draw the point here. This is yeah. If I know the radius R equals 2, okay, and here P and the Q, okay, okay. So I wanted to find out, okay, the distance between P and the Q. Okay, this is a rectangle. Yeah, this is a center. Oh, okay. And why this tricky problem? Because this is a rectangle, okay? So it is a rectangle, so therefore, for the P and the Q is the length of the diagonal, right, of the rectangle, which is going to be, let's say PQ, yeah, this is going to be O and R, but the O and R is going to be the radius, right? And so that is 2. So just simple observation. Yeah. Okay. So the circle plays some rules here when you solve the problem. Okay. Now another problem. Okay. This is from David Shen, right? David Shen has a question about the geometry problem. All right. So we have the rectangle. Okay, let's use the A and the B, C and the D, okay? The rectangle, the length of the diagonal, okay, equals half of the rectangle's perimeter less 4/5 of the length of the short side. So what is the ratio of this? Okay, so that's just the equation, okay? So here's the question. The length of the diagonal, okay, let me call it diagonal D, okay? So length of the diagonal. Yeah, should I write down the whole sentence? I'm not going to write the whole sentence, okay? So the length of the diagonal, okay, is going to be half of the parameter, okay? P is a parameter, okay? And the length is a W, right? Minus less 4/5 of the short side. So short side is W, okay? Otherwise, this is called the width, okay? So this is identity, okay? We want to find out the ratio of the length of the short side over the length of the longest side. So find the L and W. Okay, P is a parameter. Well, everything can be determined by the length of the width. Okay, so the length of the diagonal is going to be square root of L squared plus W squared, right? By the Pythagorean theorem. And the parameter is 2W and plus 2L divided by and 4/5W. So you get one equation in two variables. You cannot solve for L and W, but you can get the ratio maybe. Okay, so from here you will get W plus L minus 4/5W. Then just 1/5 of W. Okay, so you get simplify the equation. Okay, now from this equation, can you find the ratio? I think you can find it, but you cannot determine the value of the width, the length, and the width, but you can find the ratio. How do you do that? Well, this is the algebraic equation, right? So if you don't like the radical, you just square it. So you get the L squared plus W squared. Here, L plus 1/5 W squared, okay? Yes. Then you square it. So you get L squared, twice of that, 2/5 LW, and here's 1/5 squared is 25W squared. All right, so L squared is gone. Then I have W squared, so 24/25W squared equals to 5W LW. Okay. Then I think I can delete a W. So I get this. Finally, what do we have to find out? We find L, W and over L. W over L equals 2/5 times 25/24. Let's simplify this. Here's a 5. It's 12, so it's 5/12. Whoa. All right, so this is how do we solve the problem. So you write in the equation, and if it's a single equation, two variables, so you cannot determine each individual value, but you still can find the ratio, okay? If this is a homogeneous equation, we call it homogeneous equation. If it's not a homogeneous equation, no, okay? And so every term containing L or W. All right. So now we're going to take a look at the next problem. This is a regular octagon. Okay. This regular octagon has a side length of 4 feet. Okay. So 4 feet, 4 feet, 4 feet. How many sides? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, the idea is that we choose the midpoint of the alternating sides of the octagon. Okay. Okay. So what we can do is we connect them to form a quadrilateral. Okay. What is the total area of the 4 shared region? So we're going to share the region. Okay. So that's our question. All right, so those are the midpoints. Yeah, I hope you can figure it out, okay? I give you 1 minute to the computation. It involves radicals. All right, how do we find the area? So you just need to find the area for one piece, right? So one piece. I didn't get an answer from you guys. So let's try. This is a 4. Can you tell the other side? Because it's midpoint, so this would be 2. It's 2. Okay. What else we know? I think we should know the angle. We should know the angle. Okay. I think this angle is 45 degrees. Can you prove that? Okay, it's easy to see that. You can figure it out, okay, 45 degrees. The reason is the one in the middle is a square actually, right? So the square, then by symmetry. Okay, so now, once you get that, so you can get, this is the trapezoid. All you have to do is find the base of the trapezoid and the height of the trapezoid, right? In order to find the area, okay? Right, you can decompose the trapezoid, the right trapezoid into a square, 2 triangles, okay? Right? So this is a rectangle. If this, you have a right, you have a, if you have a regular right triangle. So this side is 2, then the other side will be square root of 2, and this side will be square root of 2, right? It's the right triangle. If this side is 2, how about the other side, right? Other side, is a square root of 2 and a square root of 2. Okay? So now it's clear, right? So B is going to be 4 plus 2 square root of 2. H is a square root of 2. So how to find the area of the trapezoid? The area of the trapezoid, okay, is going to be half of 4 plus B, 4 plus 2 square root of 2 times the height. Okay? So you can get 4 plus square root of 2 and multiply square root of 2. If you multiply them out, I get this. Okay? If you want to find the shaded area of the shaded region, the total area, just add them together. So sometimes you have to decompose the picture into several pictures. Okay. Our next problem I wanted to try also, and I hope you can figure it out quickly. This is a question. Let me write on the question. How many distinct isosceles triangles having sides of integral length, and I also know the parameters are fixed. Parameter is 93. Okay. So great. So think about this problem, and I wish you can give me the answer right away. Okay. Okay, anyone got 46 total? All right, let's try. Okay, this is the isosceles triangle. Isosceles triangle means you only have two variables. So you have A and B. And B, and B, okay? So in order to make a right triangle, okay, so you have a, in order to make it as a triangle, it must satisfy the triangle inequality, AB plus B greater than A plus B greater than B. That's obvious, right? So, but we also know that A plus B equals 93, okay? So first of all, those two give me only one inequality because the second inequality is trivial. So that means 2B is greater than A, okay? And here I have to simplify it. So I have a 2B greater than A plus 2B equals 93, okay? So you cannot choose arbitrary A, okay? You cannot choose arbitrary B. So you can, what do you have to do? Okay, you can try this. 93 equals A plus 2B. So A uses the equality. So again, A is less than 2B. So 2B plus 2B, it is 4B. Okay. Right. So then you will see that B cannot be too small. B is 93 divided by 4. So this is going to be 23 to 5. But on the other hand, okay, B has an upper bound. Okay. How do you get the upper bound for B? This is lower bound. Okay, so you can let A could be as small as possible. Look, right? Look, 93 is going A plus 2B. A is positive, so greater than 2B. Okay, that means B is going to be 93 over 2, let's say. So which is going to be 46.5. So there's a 2 bounds between B. And that's why B should be called 24, 25, all the way to 46. And for each such value of B, you can find the value of A, okay? A is going to be 93 minus 2B. And I think it's A, you can get, right, 93 minus 2 times 24, right? And the 48, right? So you can get the corresponding value. -3 minus 48. 93 minus 48, so 45. Okay, and let's look at the last one, right? 93 minus 46 times 2. It's only 1. So 1 is okay. You know, you draw, it looks like a very slim one, like a 46, 46. Okay, another one will be like that. I have to draw a little bit crazy notes. It's 24 and 24, right? And here's 45. And gradually, you know, yeah, so this is a 2 extreme case. In total, there will be 46 minus 23, right? That's 23 triangles there. All right. All right, so our next problem is, this is a trapezoid. Trapezoid, okay? So A, B, C, D. Okay, I draw the line. What I have here is AB equals BC equals 5. I also have a BD equals 12. And I also have the triangle DBC equals 90 degrees. Okay, so this is a 90 degree. Okay. So we want to find out the area of the triangle ABD. Okay. Find the area of the triangle ABD. Okay. Okay, so this is a triangle area. This is the area of the triangle I'm going to find out. Okay, can you have a idea? So AB is a 5. I also have BC is a 5, and the BD here is 12. Okay. Any ideas? To find the area of this triangle, right? We have to do. If you know the other side, AD, probably can find the area of the triangle, right? I think we needed to find the height of the trapezoid, right? If you're able to find the height of the trapezoid, that's my hint. Then you probably can find So first of all, DC, right? DC is going to be square root of 12 squared plus 5 squared, which is 13. Yes, right? 13. So DC is 13, that's obvious. Then how can I get the area of ABD? You just needed to know the height. The triangle ABD, H is also the height of triangle ABD, right? So the area of the triangle ABD is going to be half of 5 times H. Okay, 5 times H. So how can I find H? Any idea? Right, to find the H, there are many ways to find H. You can use the area as a triangle. The area triangle BDC is going to be half of 13 times H, right? But this is the right triangle, so it's also going to be half of 5 times 12, because 12 we can view as the height of the triangle, and BC can view as the base. So H is going to be 5 times 12 divided by 13. Okay, therefore you get the area. Okay, the area of the triangle ABD is going to be half times 5 times 13, 5 times 12. Okay, and if we express in the if we express it in the fraction, then that will be 6 times 5 times 5. It's 150 divided by 13. Okay. 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 Similarly, you can do the following problem. Supposing a triangle. Okay, I give you a triangle A, B, and C. Okay, and I know AB equals 10, BC equals 21, AC equals 17, and I draw the attitude AD. Okay, I want to find out the ratio of the pyramid of the triangle ABD to the pyramid of the triangle ADC. Okay? So got it? All right, so let's do this problem. And first of all, you have to check whether this is right triangle, then it will be much easier. But you find out 10 squared plus, this is 10, AC is going to be 17, that's 21. So 10 squared plus 17 squared is not going to be 21 squared. So it is not a right triangle. Okay, it is not right triangle. So I'm not able to use the right triangle. But can we find can we still find yeah, is there an easy way to solve the problem? Now, if you know lots of right triangles, probably it's an easy way to solve the problem. Okay, why? Because because you know that you're familiar with some right triangle has edge length 17. So you know that 6 squared plus 8 squared equals 10 squared. You also know that 8 squared plus 15 squared equals 17 squared. Okay, so if you know those identities, probably then you have 8 squared that shared. Okay, so probably you can group these two triangles together. Okay, for example, this is going to be, yeah, this is going to be 8, 10, 6. Another one will be 17, 8, 15. See, group these two triangles together, and here you get 21 total. Okay, if you are familiar with lots of other right triangles, special right triangles, you can solve the problem easily. Then the answer is, okay, the answer is the parameter, the ratio of the parameter, right? So 10 plus 6 plus 8, 8 plus 15 plus 17, and that is going to be 3/5. Okay. Yeah. So if you're familiar with a sequence, okay. Yeah, if you're familiar with you know many special right triangles with integral length, with length, you know, with side lengths being integers, and then you can solve the problem. But if you don't know, okay, if you don't know this, how can I solve the problem? Okay, if you don't know, they still have a couple ways to do this. Here's 21. This is H, this is X, this is Y. You can use a Pythagorean, you can use apply the Pythagorean theorem to both of them. X squared plus H squared equals 10 squared, okay? And H squared plus Y squared equals 17 squared. And X plus Y equals 21. From here, you can get X, Y, and H. That's a second method. Okay, and since we don't have much time left, I just show you this. So you can find the X and Y and H. Okay, the third method is I can find the H in the following way. The area of the triangle is going to be half times H times 21, but this also by the Heron's formula is going to be S minus 10, S minus 17, S minus 21. Okay, this is called the Heron's formula. Okay, S is half of the parameter. Okay, half of the parameter is going to be 10 plus 17 plus 21, right? Divided by 2, it's 24, right? 24, okay? So that means it's going to be 24. Here, 24 minus 10, right? And 14, And 17 minus, 24 minus 17, I get 7, right? 24 minus 21 is get 3. So you can get the integer from here. I'm pretty sure. Let's do it. 3 times 8 times 2 times 7 times 7 times 3. So I get double 3 here, 3. And I get 4, I get 7. Okay? So I can quickly get the area 3 times 4 times 7, which is 84. So you find the 84, then you find the h. So h is going to be 84 and multiply by 2, divide by 21. I don't think we can simplify. We can simplify, right? So that will be 4 times, it's going to be 8. See, you get an 8 the same way. See, so 3 different problems. When you have time to think about that, there's 3 different methods to solve this wonderful problem. It's a very nice problem. If you memorize lots of special triangles, then you can quickly use the first method and group the 2 triangles together to form it. That's a quick way to do. But not everybody can figure out that. Suppose you don't know this, then the second method is very natural. Just name the variables and apply the Pythagorean theorem to 2 triangles. Then you get 3 equations because the space is x plus y equals 21. Okay, so that's all about today's geometry problems. Okay. Yeah, we already discussed many problems on the numbers, but we will continue. I know we should have a couple more lectures on numbers. Right? Geometry probability should be also covered, right?